Azure Cosmos Database. Azure Cosmos DB is a fully managed NoSQL database for these modern apps that don't really need a rigid schema of a relational database. It's totally SLA backed, so you have a service level agreement backed for availability and security. It enables very fast scaling globally. Right, so it handles that capacity management with cost-effective serverless and automatic scaling, and there is a support for open source APIs. Some of the benefits of the Azure Cosmos database is that it has fast global access. So real-time access with really fast read and write latencies all over the globe, and throughput and consistency all backed by SLAs. We also have instant elasticity, so we can scale up and scale down instantly as needed, and elastically scale storage. So independently and elastically scale storage and throughput across any of the Azure regions, even during your unpredictable traffic bursts, right? So you can unlimitedly scale worldwide. Application development becomes a much easier process now with the Azure Cosmos database. You can build fast with these open source APIs and support for multiple SDKs. It's deeply integrated with the Azure services, right? So you can include your Azure functions, any IoTs, Kubernetes services, app services. You can choose from multiple database APIs, including the native core SQL API. There's an API for MongoDB, Cassandra. There's a Gremlin API and a Table API. So there's a lot to choose from the API offerings. You can run no ETL analytics over near real-time operational data stored in your Cosmos database, and it's a schema-less service. So again, it's not like a relational database where you have a schema, it's schema-less. So that allows us to store our information and use it much more dynamically. Azure Cosmos database service level agreements. Availability is 99.999% guaranteed. We've also got continuity in the service level agreement, so we can distribute our data to any other regions with automatic data replication. And with that, we have zero downtime because we can use multi-region writes or an RPO 0 with strong consistency. And security. So we've got enterprise-grade encryption at rest with self-managed keys, and you can incorporate Azure role-based access control to keep your data safe and only have the people who need this data and work with this data have access to this data. So what functions make up the Azure Cosmos database? First of all, it's a complete database service. It's end-to-end management with serverless and automatic scaling to match your application needs, right? So there's no touch, no maintenance, no patching. You just use the database for what you need to use it for. It's serverless. So if you have spiky workloads that you need to respond to quick, that can handle that. You can manage traffic bursts on demand and not have to worry about any of the underlying infrastructure. It enables automatic scaling, instantly scales capacity for unpredictable workloads, and it's cost effective. So by being able to scale out and scale back in based on your sporadic workloads, you're not paying for servers idle. And on the other hand, we're not renting out physical servers to put in our data center just to sit there in case the database gets a high load, right? So it's cost effective. They all tie together. It's serverless. It'll automatically scale in and out. And as a result, that makes it a very cost-effective solution. So what are some of the uses for Azure Cosmos database? First of all, the Internet of Things. right? So we got massive amounts of IoT devices all over the world, whether it's on oil pipelines or traffic intersections, right? We are using these devices to send data that we would normally never have. A lot of this data is not in a schema, right? A lot of it is going to be different and dynamic. So by using a schemaless database, we can store all these data from all these different IoT devices. Great for retail. We can store a lot of our information about our customers. A lot of the times the customers don't give us all the same information. So again, that schemaless design is a big advantage here. Great for gaming. So your leaderboards, all your gaming related information that you need to store during a game session data, whatever the case may be, great for that option as well. And mobile applications. So again, these web and mobile applications are becoming very dynamic and again, schemaless. So we need a schemaless database, and Cosmos is exactly what we need for any of these IoT, retail, gaming, mobile apps. These are your key use case scenarios for an Azure Cosmos database. Now let's take a look at the Azure Cosmos resource model. So the Azure Cosmos DB is a fully managed platform as a service. So you just create your DB account, then you can go ahead, start creating containers and items under it, right? It's also global distribution and availability. So we can use multi-region writes and multi-region reads. And that allows us for maximum uptime and availability. And we can globally distribute our data all over the world to make latency less for our users who are situated in different continents all over. It also provides you with a unique DNS name. So what that allows us to do is that it provides us with a unique DNS name so we can manage our account in the portal, in the command line, or using any language-specific SDKs. And single or multiple write regions. So as we mentioned before, this goes hand in hand with global distribution and availability. Right? We can have a single write region, or we can use a multiple write regions to increase our availability and to get our data out all over the world, distributed globally. Let's take a look at the elements in an Azure Cosmos account. The Cosmos container is your fundamental unit of scalability. You can have any basically unlimited provision throughput and storage on your container. The Cosmos DB transparently partitions that container using the logical partition key that you specify in order to scale your provision throughput and storage. You currently have a maximum of 50 accounts under your Azure subscription. But again, this allows you to scale fundamentally based on accounts. It allows us to manage subscriptions. So again, you can have a maximum of 50 at this point. The Azure Cosmos databases. What databases can we spin up under an Azure Cosmos account? So basically, we have our Azure Cosmos entity, and that allows us to spin up multiple databases, or even one, depending on what we want to do. The database itself is the unit of management for a set of Cosmos containers. So first we can use the SQL API database. This is the core default offering. It allows us to create our databases using the SQL APIs. We also have the Cassandra API, which is another database that we can spin up. The Azure Cosmos DB API for Mongo database gives us the opportunity to run a Mongo database. We have the Gremlin API available to us. We also have the Table API to us. So these give us many different options on how we want to store and present our data. So there's no shortage of different options when you create a database. The Azure Cosmos database operations. Right, first thing we need to do is create. Create allows us to essentially, you guessed it, create our database. Once there, we enumerate all of our databases. We keep a good track of them. We know what databases belong to what accounts and what subscriptions. We read the database, and we update our database as we see fit. So that may be patches, that may be more horsepower, right? But this is kind of this cycle of a Cosmos database operation. The Azure Cosmos containers. The containers are your unit of scalability for provisioning throughput and storage. It is horizontally partitioned and then replicated across multiple regions. Any items we add to a container are automatically grouped into logical partitions, which we then distribute across physical partitions. When you create your container, you can configure throughput in one of two ways. You can have a dedicated provision mode. So this is exclusively reserved for that container. Any provisioning of throughput is exclusively used for that container, and it's backed by the service level agreement. We also have the shared provisioning. So these containers share the provision throughput with other containers in the same database. So depending on your needs, you may choose dedicated as opposed to shared. Or if it's something in development, maybe you should share the throughput and use dedicated for just your production environments. These containers are automatically indexed, so you don't have to specify an explicit index or schema management. We'll use arbitrary schemas, right? So schema agnostic container. So an item that represents a customer and an item that represents an item can be placed in the same container. All items that you add to a container, again, are automatically indexed. And we can also set the time to live on selected items, so we can purge them out of the system after they pass the specified TTL. So Cosmos will automatically delete the items when they expire. And it also guarantees that a query performed on the container don't return stale data. In this video, I'm going to demonstrate how to provision an Azure Cosmos database. So once we're inside the Azure console, the easiest way to find any of the products is to come up under the search bar. You can also see it over here on the left-hand side. Right, I can scroll down and find Azure Cosmos database and go ahead and click it. And it brings us to the Cosmos database console. So right now, I have no databases created. If I did, they would be here. So I'm going to go ahead and click Create Azure Cosmos Database Account. Once I click it, it brings me into the creation screen. So I have a few things to set up to provision this database. First of all is my subscription. I have to choose my subscription. Right now I'm on a pay-as-you-go subscription. If your free trial has ended, you may have to upgrade to a pay-as-you-go. So go ahead and click the appropriate subscription. Next, we have to select a resource group. So resource groups are when we group together our resources that all share the same life cycle and same permissions, right? So it allows us to easier manage a group of the same resources, so to speak. So I'm going to create a new one, and I'm going to call it Cosmos DB. So all the Cosmos database groups now I will put into that resource group together. Next we have account name. So this is to uniquely identify our Cosmos account. We're always going to append documents.azure.com to the name, so we have to make sure that our name is unique. So I'm going to go ahead and put Richard Cosmos Demo and hope that that is unique. It appears to be okay, shown by the checkbox. Next, we choose our API. So we can select the core to create a document database and query by using SQL syntax. We also have a few more options. So the API determines the type of account to create. right? The Cosmos DB provides us with 5 APIs. Core SQL and MongoDB for document data, Gremlin for graph data, Azure Table, and Cassandra for table-based data. So currently you have to create a separate account for each API. I'm going to go ahead and choose Core SQL and come down to Notebooks Preview. I can turn this on, I can turn it off, right, if we want to incorporate it with our notebooks. In this case, we don't. Next, we have location. So here's where we can put it in a specific region. So US West, Asia Pacific, Canada, depending where you're located. I'm going to go ahead and leave it on US West. Next, we have capacity mode. So we can have provision throughput, right, where we actually specify a specific throughput that we want to provision. We also have a serverless option, right? So once we click serverless option, you'll notice that all of these provisioning configuration is gone because, again, the whole concept of serverless is that we don't actually do any configuration and provisioning with this server. So I'm going to leave it on provision throughput so we can actually provision the capacity we want. So you'll notice a little note that says with the Azure Cosmos Database free tier, you'll get 400 RUs and 5 gigabytes of storage for free in your account. Right, so do I want to apply a free tier discount? I do in this case. We can also select our account type. So is this a production environment? Right? Or is this a non-production environment? Is this going to be like a development or testing or staging? This is just a resource tag that tunes the portal, but doesn't affect the underlying Cosmos database itself. You could change this value at any time. We can also enable or disable geo redundancy, right? So we can add more regions and make sure we have a redundant Cosmos database over multiple regions. And we can turn on multi-region writes. That allows us to take advantage of the provision throughput of our databases and containers across the globe, so multiple regions. I'm happy with what I set up. I'll go ahead and click Next for networking. So how do we want our database account to connect? Do we want it publicly, just over service endpoints? Do we want to use a private endpoint? Right? If you leave it on all networks, and all networks will be able to access this Cosmos database account. A public endpoint allows us to kind of fine-tune what networks. So do we want to allow access from the portal? Yes. And then allow access from my IP. So it kind of adds firewall entries for you. And we can use a virtual network as well, if we had a virtual network created in our Azure account. And private endpoints. So if we had any private endpoints created, we can use that to access the Cosmos database account. I'm going to leave it on all networks right now and click Next for backup policy. So we've got 2 different backup policies, and you can't switch between backup policies after the account has been created. So we've got periodic, which is a backup interval of every 240 minutes, and it retains 8 hours, and it retains 2 copies. We can also set a continuous backup policy, but we have to go and sign up to enable that continuous backup policy. So we're going to leave it at periodic, right? We're going to back up every 4 hours, and we're going to make a backup retention of 8 hours. So I'll go ahead and click Next for encryption. How do we want to encrypt, right? It's always encrypted at rest by encrypting the data in the data center using service managed keys. You can also choose a customer managed key if you wish to manage your own key. I'm going to leave it at service managed keys. I'm going to click Next. I can add any tags here. So I'm going to say created by, and I'm going to give it a value of Richard. So these are key value pairs that we can kind of use to track our resources. So I'll click next for review and create. It shows me all the settings I created and the estimated account creation time. So it's going to be about 15 minutes. I scroll down to make sure everything is fine. I can download a template for automation for next time, right? So I can make this much quicker. Infrastructure as code, right? We can download the template and we can recreate this much quicker. I'm going to go ahead and click create. You'll see the pop-up come up, initializing, then submitting the deployment. Now the deployment is in progress. So if I want to download the deployment details to store in a repository or some deployment software, I can do that here. In the meantime, we just have to sit and wait until the deployment is finally configured, and that should take about 15 minutes. As you can see, once the deployment is complete, it tells you, and it tells you that you can click here to go to the resource. So I'll click here, brings you right into my Cosmos database, where we can do some configuration and fine-tune the database exactly as we need it to be. So I hope this video showed you how to provision your first Cosmos database, and stay tuned, we will get into the actual configuration of that Cosmos database. In this video, I'm going to demonstrate how to configure an Azure Cosmos database. So we want to get into our Cosmos database console. I come over to the drop down on the left and choose Azure Cosmos DB. I go ahead and click it. I'm brought into the Cosmos console. Any databases you have will be displayed below. I'm going to go ahead and click my database, and it brings me up a configuration window. And on this screen, I normally collapse the left-hand side so I can get all my configuration details on a larger screen. So here's where you can configure the database how you want it to be. We can see some of the things we set up: the resource group, the subscription, the URI, where we can reach it from the outside world, the read and write locations. We can come down and we can add some containers, should we want to. And we can view our monitoring, so over 1 hour, 24 hours, 7 days, or 30 days. Here's where we can configure some of our access control. So who do we want to grant access? We can view my level of access. We can grant access to the resource and then view that level of access to make sure that we haven't given more access than what they need to do their job. Under settings is where we can really do a lot of the fine-tuning of this database. So if we click features, we'll see some of the features that we can turn on or off, like the Azure Synapse link. Replication, so if we click replicate data globally, here's where we can come in, click on locations, and add or remove regions from our Cosmos database account. So right now, multi-region writes are disabled. If I were to click enable, now we have to click what other regions that we want to actually configure it for, right? So we want US West, UK South, and Canada East to be multi-region writes, and reads are enabled as well. Now, this takes us out of the Cosmos free tier, so I'm going to go back and disable it. But one thing to remember is each region is billable based on the throughput and storage for the account. So you can keep adding regions, but it will start to get really costly. So I'm going to go back to disable, but that's great for disaster recovery. It's great for failovers, right? But you kind of got to fine tune it so you don't spend too much money right? So got to be a really good trade-off between efficiency and cost. Okay, so over here now you can still see that we've got some read regions. So when we click these, we're actually clicking read regions as well. So I'm going to go ahead and delete these as well, and I'm just going to have one write region. Okay, now if I wanted to create a read region or read replica in another area, say in Brazil South, maybe we have a lot of users in Brazil and we want to offload a lot of the reads on our main database, we can create a read region down there, right? And by turning on or off, this would make it multi-region writes as well. So here's where we configure our additional reads and our additional write regions. We can, after we turn off our additional read regions, we can come and click default consistency, right? So here's where we find our consistency. We can choose strong consistency. It's the most predictable and intuitive programming model, right? Reads are guaranteed to see the most recent write. Bounded staleness. If you're using, say, globally distributed applications that are expecting low write latencies but total global order guarantees, right? So our maximum lag time can be 5 seconds in this case. And it gives you a little demonstration below on how this consistency will work. We can have session consistency, single region usage, as well as globally distributed applications. You have write latencies, availability, and read throughput comparable to eventual consistency, but you also get some consistency guarantees that are good for applications written to operate in the context of a single user. We also have consistent prefix that'll guarantee that reads never see out of order writes. And eventual consistency, again, replicas within a group will eventually converge and eventually all give you the proper result that you're looking for, but it's eventual. So you may have one client that gets an older value than another client. So eventual consistency is good when the application don't require any ordering guarantees. So these are your consistency choices. Obviously, strong consistency, going to pay a lot more for it than eventual consistency. So I'm going to leave it on session the way it was. And now I'm going to look at my backup and restore configuration. So we set this up originally when we provision. So we're saying how often do we want our backups to be performed? Every 240 minutes. And we like to back up 8 hours of data over the course of 2 copies. More firewall settings are here. Again, we set this up originally. We can come in and change them as we wish. Same with private endpoint connections. So if we had a private endpoint, we can use that to connect with our Cosmos database. CORS, or cross-origin resource sharing. If you've got a web app in one domain that needs resources in another domain, you have to turn on CORS. Right? So once you set the CORS rule, then requests will have to be properly authenticated. And if they are authenticated, then you can pull resources from another region. Keys, right? Read keys and read-only keys already given for us. We just need to copy them and we can use them in our API calls. We also have Azure Cognitive Search. We can add Azure functions. So we'd have to create a container, and then that function would run in our container. We also have some advanced security that we can turn on. This will help us against a DDoS and a lot of the kind of threats that would attack our API. And our locks are here as well. So if there's any locks, we can look in and find them here. Here's our container settings. So if we had containers, here's where we would find them. So with our Data Explorer right now, we don't have any. So we can add a container. So I'm going to say Richard container. I'm going to leave the throughput on the lowest possible. I'm going to call it container demo. I want automatic indexing. And I want my partition code to be, say, user ID. And I'm going to leave the analytics store off. I go ahead and click OK. You can see it's creating a new database. Successfully created database Richard container. And now when it refreshes, my database container is here. Okay, so once I'm in the container, I can start with sample data, which I did here. Right, so once I'm here, I can scroll down. I can look at the container demo I just created. If there's any items in there, like any database or any data, I can see it. Any stored procedures, any triggers, any functions, they're all here. So if I want to add a new item, I can add a new item from here. Or I can go ahead and upload an item. So a JSON file, for instance. We also have some configuration for metrics. So we've got metrics like average throughput, data sizes. We can create alerts based on those metrics to keep a more proactive approach to our database. So I hope this video showed you how to get into your Cosmos database and do some configuration, whether it's replication, multi-writes, read replicas, whether it's the consistency, is it going to be strong or eventual consistency, backup and restore configuration, and container configuration. So get into the database, play around, and make it work for your application so you can take advantage of all the rich features that the Cosmos database has to offer you. In this video, I'm going to demonstrate how to query data from an Azure Cosmos database. So once we're inside of our Azure portal, we have to go into our Cosmos database. So I'll find the Cosmos database link on the top, or I can come over to the left, find the Azure Cosmos database, and click it to enter the Azure console. Here's where you will see your previously configured and provisioned database. And this is the database that we want to load data into and then query some data out of. So go ahead and click your database that you have created. It'll bring you into the configuration. And again, I normally collapse the left-hand side of the screen so I can see all my configuration options. So we want to go over to the left to Data Explorer. Once that fetches the database, we can get started with a simple database, or we can create a new container. I'm going to go ahead and start with a sample. So I click Start with Sample. So I expand it, and you can see the persons. So when I expand persons and come into items, here's where some of our data is. Right? This is a pre-populated example. So they put in the data for us. Now we have to query some of it back. So here's where you'll see your filter. Select all from C. So C is the alias for this table. So in order to query data back, we should look at the fields. So ID and / first name. We've got a total of 4 entries. So let's do some querying and pull the data back. So once we're here, I can click each entry and see it pop up on the right-hand side with the name, the age, the ID. I can click the next entry and I can see John, and I can go through. So this is a good way to kind of look through your entries, but if you got thousands of database entries, this is going to take a long time. So we want to see the filter. So there's different ways that we can change the filter to pull back just the data we want. So I can change the order. So I can say select all from C, order by, and then I'll just say C.ID, descending, and it changes it to descending order. If I want to change it to ascending, I can click edit filter and change it to ascending. And then we see it change because of the order by ID. I can also query just for someone whose name is John. So I can say select all from C, where C.firstname equals John. I can apply the filter and it will pull back just the entry with John. I can also query on age. So I can say select all from C, where C.age is greater than 30. Apply the filter, and I just get back Veronique, whose age is 50, and Eva, whose age is 44. So that's some of the stuff that we can query on. You need to go into Data Explorer, and you need to edit your filter. And again, you can filter on all of the different values, like first name, age, ID. We can also change the order, so ascending or descending, right? So this is how you pull your data out of your Cosmos database without having to go through each and every entity in the database. So go into your Cosmos database, add some more data, and start playing around with the filter to query out exactly the data that you or your application will need to use. Now let's take a look at the Azure Cosmos database. The Azure Cosmos database is globally distributed and elastically scalable. So we can distribute it all over the world no matter where our clients are, and we can scale it up and down elastically based on demand. It's guaranteed low latency, and that is backed by comprehensive service level agreements. We have 5 consistency levels. We have strong consistency, bounded staleness consistency, session, consistent prefix, and eventual consistency. These offer different levels of consistency, and they obviously come at a different price point. So the Azure Cosmos DB, the core SQL API. This is the default API for the Azure's Cosmos database, and it provides you with a view of your data that resembles a traditional NoSQL document store. You can query the hierarchical JSON documents with a SQL-like language. You can use select, you can use from, you can use where, between, count, you name it. And it also uses JavaScript type system and expression evaluation in addition to function invocation. So these are these JavaScripts that we can incorporate with the core SQL API. MongoDB API is a Mongo database wire protocol. This API allows existing Mongo client SDKs or drivers to interact with complete data transparency, as if they're running against an actual Mongo database. The data is stored in document format, same as we did for core SQL, and we can use these Mongo APIs to interact with the Mongo database as if it was actually interacting directly with the database and not the database APIs that Azure is offering. Very easy integration. Now let's look at Cassandra API. So Cosmos DB support for Cassandra API allows us to query data using the Cassandra query language, or CQL. Your data will appear to be partitioned row store, but just like the MongoDB API, all the clients or tools will only connect transparently to the Azure Cosmos DB, and only your connection settings should need to be updated. If you have any experience with the CQL query language, Azure Cosmos DB provides some familiar statements like create key space, create table, alter table, and so on and so forth. And you can check all that out in the documentation. And the Azure Table API. The Azure Table API offers us high availability with global distribution, and it's flexible and scalable throughput. So the first table API only allowed for indexing on partition and row keys, and there were no secondary indexes. Now when we store table data in Cosmos, the database automatically indexes all the properties, and it doesn't require you to manage any of the indexes itself. We can query the Azure Table API by using the OData and LINQ queries in code and the original REST API for GET operations. So this is an option for you if you want table storage. And finally, Gremlin API. So Gremlin API is data stored in the ARS format. It gives us a graph-based view of our data. And to query a graph database, Azure Cosmos DB supports the Apache Tinkerpop's Gremlin language. So remember, at the lowest level, all data in the Cosmos database is stored in an ARS format. But this graph-based view means that data is either a vertex, so an individual item in the database, or an edge, so it has some relationship between these items in the database. In this video, I'm going to show you how to use the core SQL API with Microsoft Azure Cosmos Database. So we're going to do some common commands that'll automate creation and management of our Cosmos databases, the accounts, and any containers. We're going to use the Azure Cloud Shell using the Bash environment. The same commands should also work in the Azure command line. So first thing we need to do is come up to our top bar here and find the Cloud Shell. That'll give us a shell that directly interacts with our Azure environment. So I'm going to go ahead and click the shell, and it opens up in the bottom. So in this case, I want to see a bit more. So I'm going to open it up. Okay, so now you see I have a Bash shell. So let's go about starting to create our database account for starters. So we need to create the database account. So I'm going to paste in some text, and let's take a look. So I'm giving the resource group name Cosmos DB. This matches up with the resource group name I've already created. And I'm giving the account name as Richard Spencer. Down below, you'll see the command to create the database. So az cosmos db create, use the account name given above, use the resource group name given above. We want default consistency level of session, and we just have a region in West US. So if I go ahead and run this command, you'll see it blink a few times. Normally, if this could take as long as 5 to 10 minutes, so if it blinks for a long time and doesn't give you an error back right away, you're probably in good shape. Once the account has been created and succeeds, you'll get an output of what you created, all your document endpoints, any failover priority, all your IDs, if it was successful, the resource group, so everything is there. So next, let's update from a single write region to multiple write regions. So I like to kind of clear my screen so I can get a good look at it. And I'll paste in commands. Same thing, we put in our resource group name and our account name. Next, we want to get the account ID for our account, and then update it to enable multiple write locations. So I hit enter. This one doesn't take as long as the previous. And again, once that is finished creating successfully, you get your printout of all your endpoints and the successful status. So I'll clear the screen again. At this point now, we've created our account. We've updated the account from a single write to a multiple write. So now let's go ahead and add a region. So I'll paste in my code. Again, you always put in your resource group name and your account name. Then we're going to run the AZ Cosmos DB update API. I attach my account name. I attach my resource group. And I'm adding locations US West, US East, and South Central US. Failover priority for West will be 0. Then we fail over to East US, and then finally fail over to South Central US. So I go ahead and run these APIs and wait until we get the successful message come back. So once that's finished, we get our endpoints again and our success messages. It gives us the URLs for our endpoints that we can click on, right? So I'm going to clear off the screen again. And this time I'm going to do something different. I'm going to show you an API to list your connection strings. So we run the AZ Cosmos DB keys list API with our account name and a resource group name, and then type of connection strings. Hit enter, and we get all of our connection strings available for whatever framework we're using. So we can scroll up. We can see all of our account endpoints. Tells you if it's the primary, the secondary, the primary read-only, or the secondary read-only. So every connection string we have, we can take it from here and use it as we see fit. The last thing I want to do is to create a database. So we'll run the AZ Cosmos SQL database create API, and we'll create a database called database1. So we run the API, AZ Cosmos DB SQL database create. We reference our account name, we reference our resource group name, and our database name. So I go ahead and hit enter. It's running the database create, and that relatively quick finish. Then it shows us the name of the database, resource group, and the type. So once we're happy with our database and our account and how everything is set up using the APIs, if you want to double check in the console, you can go into Azure Cosmos DB. I can make the bash shell a little smaller. Here's where you can see the account we created. I'll click on that. You can come up to Data Explorer, and we can see that the database we created, database 1, is here. And we can also make sure that our read locations and write locations are what we set. And they are, because they're West US, East US, and South Central US. So I hope this video showed you how to get in and use these core SQL APIs to manage your Cosmos database from a command line, right? Or the bash shell, whatever you prefer. But it helps for automation, right? We can automate these accounts and databases and containers and everything else that we want to create in Cosmos from the command line using the APIs. So get in, play around with some of the different APIs, and discover how powerful that these Azure core SQL APIs are for your Cosmos database. In this video, I'm going to demonstrate how to create a database and a collection for MongoDB API using the Azure Cosmos DB. So you can do this one of two ways. We can download and use the Azure command line interface, or we can use the Cloud Shell that's already integrated with the console. So I'm going to go ahead and click the Cloud Shell, and it should open up a bash shell environment for me to use against my Azure resources. So the first thing we need to do is add our variables for our various API resources that we're going to use. So in this case, I'll paste in the code, and here are our variables. So we're saying the unique ID can be random. The resource group name should be group dash the unique ID. Our location is in West US 2. Create the account name of Cosmos dash the unique ID. We specify our server versions. We give the database a name of database 1 and a collection name of collection 1. So we go ahead and hit enter. And at this point now we are setting our variables. And now we can go ahead and use them in future commands. The next thing we want to do is create a resource group. So if you can remember, resource groups are used that we can group all of our resources that share the same timelines, share the same life cycles and permissions. So we want to go ahead and use the APIs to create a group. So we type in AZ group create. We give it a name of resource group name. So this is the variable. It comes back up, looks at resource group name, and applies it here. And it does the same thing with location. So it'll put it in West US 2. So I go ahead and hit enter. And we get a success back. It shows us the group name. It's going to be group 7089. So once we're happy with our group, let's go ahead and create the Cosmos account for MongoDB. So we'll again use the APIs. You can do this from the Azure command line. You can do this from specific SDKs. For this demonstration purposes, I like to use the console terminal. So I'll go ahead and I'll paste my code in. AZ Cosmos DB create using the account name and the resource group name that we specified above when we set our variables. A kind of MongoDB. The server version references the server version above, which we set. Default consistency level is set to eventual. And we've got two locations, US West 2, US East 2, failover priority of 0 for West and priority of 1 for East. So let's go ahead and create this Cosmos account. I click enter. This may take upwards of 15 to 20 minutes. Once our account is created, we can go ahead and create a database. So we say AZ Cosmos DB Mongo database create. Use the account name, resource group name, and the database name that we specified in the variables beforehand. So I go ahead and hit enter, and we wait again. It's running. This doesn't take as long a time as the account creation takes. Once that's created, it gives you the output, the resource group, its ID. So we've created the database. Now we should go ahead and define an index policy for our collection. So we're going to set a unique index and a 30-day time to live. So if we look at our code, we're saying index policy equals the value of the concatenation less than the end of file line. We want a unique key and I want it to expire after 30 days. So I go ahead and click enter. It's created our index policy. So now all we have to do is go ahead and create a MongoDB API collection. So I put in my code and I'm making the following API calls: AZ Cosmos DB, MongoDB collection create, and I'm giving it the account name, the resource group name, the database name, and the collection name, the shard of my user ID, throughput of 400, and I'm attaching the index policy above. So I hit enter. It runs. Once this gets created, we can take a look in the console and get a visual representation of what we just created using the APIs. Once that gets created, we see our output and we see it's been successful. So let's take a look in the console itself and take again another visual look at what we just created. So I come into Azure Cosmos DB. I can see my subscription here, my account, Cosmos-7089. When I look over, I can see my URI endpoint. It is the Mongo database that we created. My collection is here, my database is here, and my throughput is here. So I hope this video showed you how to use the MongoDB API to go into the command line and create your MongoDB API account and databases and collections. So get in, run some of these commands, and create that database and fine-tune it exactly to the needs of your application or your organization. In this video, I'm going to create an Azure Cosmos database using the Cassandra API. So first I want to go up and click Create a Resource. And then it'll bring me to a list of resources I can create in the console. I'm going to go and select Databases. And I'm going to select Azure Cosmos Database. So I click it. It brings me into the account creation. So I choose my subscription. It's a pay-as-you-go. And I have to choose a resource group. So I have a resource group created for all my Cosmos databases. The resource group ensures that all these resources share the same life cycles and permissions. I'm going to create an account name. I'll call it Richard K. Spencer Cassandra. And under API is where we select the Cassandra API that we're going to use. I'm going to leave the notebooks preview off. I'm going to leave my location in West US. I'm going to leave it on provision throughput. If I select serverless, you'll see that I don't really get to choose any of the provisioning that I want to do because it's serverless. I'm going to go with provision throughput, and using the free tier, I get 400 RUs and 5 gigabytes of storage. I'm going to apply that free tier discount. It's going to be a non-production site, and I'm going to disable geo redundancy and multi-region rights for now. Under networking, I want it to be publicly available, so I'll leave it at all networks. We could have a public endpoint where it's only selected networks can access it, or a private endpoint where it can only be accessed privately. I create a backup policy, so I want to run the backup interval every 240 minutes, and I want to back up 8 hours worth of data. And I'm going to use encryption using the service managed key. So I can add any tags here if I want to keep track of my resources. I click Review and Create. Tells me how much time is estimated. Everything looks fine, right? I made sure I have the API of Cassandra, so I go ahead and click Create. It says 15 minutes. Sometimes this can take up to 15 or so, depending on your location. So once the deployment is complete, we can click Go to Resource, and it'll bring us right to the Cassandra API database that we just created. So you can look and we can see the resource group, the subscriptions are everything that we set. We have our Cassandra endpoint. Okay, so let's go into Data Explorer and let's create some tables. So I'll come over and I'll click New Table. It's asking me for a name, so I'm going to call it Table 1. From here, they create the key space of Table 1, but now they want me to go ahead and enter the CQL commands to create that table. So I'm going to say create table, table 1 dot, in this case, user. And I want the fields user ID, that's an integer, name, that's text, email, that's text, and specify the primary key of user ID. So this is the Cassandra query language working right in front of your eyes. We're creating the key space, then we're putting in the CQL commands to create the table under that key space. If you wanted different fields, maybe if you want to add address, we can go ahead and add address, and we'll say text and another comma. So I just added in address as well. I come in, I set the throughput to 400. I could set it to auto scale if I need to. And I click OK. From there, you can see the CQL queries running. Now we have our table. That's called user. You can see the rows that we created, addresses there, email, name, user ID. And you see all of our options above. So we've got CQL query builder, query text. We can run queries. We can add a row. So if I click add row and I want to say add the address 34 Sunset Drive, the email is richard@spencer.com. My name is going to be Richard and my user ID will be 10. So I add the row, successfully added that row. I can come up, I can add another row. So I can say the address is 1 Sunset Drive and the email is richard@sunset.ca. The name is Rick and the user ID in this case is 14. So I add the row. Now the row goes in. I can edit rows, I can delete rows, I can run new queries. So I can add a new clause and say where user ID is equal to 10, and I can run it, and it brings me back just the user ID of 10. We can do that on any of the fields. You can also come over here and use your scale and settings, so we can update our scaling. A few other items of interest in the Cassandra database is replication. So we can enable replication for multiple writes, and we can select where we want to be able to do it. So we have multiple regions for reading right now. We could enable multiple writes as well. We can change our consistency levels. Right now we're using session consistency. All of our changes for firewalls and any other settings are here as well. And if you want to look at like locks or any long-standing queries, we can find them under here and in the monitoring sections. So most of these settings are the same amongst all the DB offerings. What we really do our heavy lifting for, again, is under Data Explorer, where you see your namespace, you see your table, you can create your rows, you can scale it. Once you're in rows, you can open up the query builder, you can query text, you can run a query, add rows as you see fit. And your connection strings are important because you want to be able to connect, whether it's an SDK, whether you're using it in Java or Python, you need to be able to connect to this database. You need a host. So in this case, this information is very important as well. So I hope this video showed you the basics on the Cassandra database, how to set up the account, how to set up the namespace and the table, add some rows, do some querying, and give you the information to connect to your outside sources and applications. In this video, I'm going to create an Azure Cosmos database using the Table API. So once we're in the Azure console, our first step is to click Create a Resource. Once we get in here, we come down to Databases, and we find Azure Cosmos Database. So we click it. It brings us into the Azure Cosmos Database account creation screen. So my subscription is pay-as-you-go. I need to have a resource group, so I'm going to add it to the Cosmos Database resource group. So any resource in this group shares the same life cycle, shares the same permissions, and so on. I give it an account name. I'll call it Richard K. Spencer Table API. And now I choose my API. So I am going to choose the Azure Table. I want to leave the notebook's preview off. My location is fine in US West. I'm going to use provision throughput, and I'm going to get 400 RUs and 5 gigabytes of storage under the free mode. It's a non-production account. I'm going to disable geo-redundancy and multi-writes. I come over to networking. I have 3 options. All networks for publicly available. public endpoint for some selected networks, and private endpoint to be able to access the database account from a private network. I'm going to leave it on all networks so it's publicly available. Backup intervals I'll set as 240 minutes. So every 240 minutes, backup 8 hours worth of data. I'm going to choose service managed keys for my encryption. I can add any tags that I wish here. I click review and create. It shows me everything that I set up. Tells me it's going to be about 15 minutes to create. So I click create, sit back and wait until the deployment is complete. Once the deployment is finished, it'll come back as complete, and we can click go to resource to see our newly created resource. So you can see our Azure Table endpoint is here. We can copy it if we needed to. We can tell that it is a Cosmos DB, and it says it has been created. And now it gives you some quick starts to connect your existing Azure to, say, a .NET application, a Node application, Java, or Python, right? So it shows you how to make that connection. If we go into Data Explorer, we can take a look around. In the console area, we can go ahead and we can create a new table. It's asking for a table ID, so I can call it container 1. And I'm going to stick to the 400 RUs with 5 gigs of storage. So I go ahead and click OK. At this point, I've created the table ID called container 1. Once that is finished provisioning, it'll come up on the left-hand side. I've got a tables DB. In it is container 1. Here's the entities. So once we're in, we can add an entity. You'll notice that you have to specify a primary key and a row key for every entity. They're unique identifiers for each entity, and together they form the primary key for each entity. So my primary key will be household tasks. My row key will be 001. The task will be take out garbage, and it's assigned to Richard. So I add this entity. We can see now the partition key is household task, the row key is 001, it's assigned to Richard, and the task is take out garbage. There is nothing in the product key. That's the beauty of schemaless. If I wanted to put in one that had some product that we needed to use, I can add that there. So if I add another entity, I can say the partition key is still the same, household tasks, the row key is 002. It's assigned to Sean. We need some Mr. Clean as a cleaner, and the task is to scrub the floors. We can add this as an entity, and now we see that there as well. So we're adding entities. We can update these entities. We can modify these entities. We can query based on entities. So I can add a new clause, and I want to say where the row key is equal to 2, and it will bring me back just by running the query, just that one row. I can also say where this is assigned to Sean, and I can bring back all the household tasks that are assigned to Sean. A few other things we should look at in the table API, account level throughput, right? So we can turn on provisioning throughput. We can turn it off. Replicate data globally, so we can turn on multi-region writes. And we can also specify other regions that we want to use. We can look at our consistency. So right now we're using bounded stateless consistency. These are for applications with low write latencies, but need total global order guarantees. Backup and restore is here, so this is the original settings we set up. And we're also going to want to look at connection string, right? We need this to connect to our SDK so we can interact with that table API. Once you do that, you have full availability to interact with your API, whether you're using Python, Java, right? The Cosmos SDKs are out there for Python, Java. So get in, create a table API, join it to your application using whatever SDK you use, and take advantage of this great table API database service from Azure. In this video, I'm going to demonstrate how to provision and query an Azure Cosmos database for Gremlin. So first you need to install the Gremlin console. Recommended version is 3.4.3. And if you're running the Gremlin console on Windows, you need to install the Java runtime. So the first thing we want to do is create a database account. So we'll click Create a Resource, and then we'll scroll down to Azure Cosmos Database. We can go ahead and click the Azure Cosmos Database to go in and create a new account. So our subscription is here, pay as you go, and I'm going to create a new resource group, and I'm going to call it Gremlin, just so I can sort all my Gremlin databases by lifecycle policies, permissions, these type of things. So my account name, I'm going to give it Richard K. Spencer, and under API is where we select Gremlin. So this is going to be our graph table. Capacity mode, we will leave at provision throughput. Apply the free tier discount. This is a non-production account type. We don't need geo redundancy and multi-region rights for this demonstration, but they're great for a production environment. So I'll click Next for networking. Available to all networks. Our backup policy is here. We'll back up every 240 minutes, and we'll back up 8 hours worth. We are going to use data encryption using a service managed key, not our own. We can apply any tags here should we wish. And now review and create. So it tells you it's about 15 minutes creation time. So I'm going to go ahead and click create. In the meantime, we can go ahead. Once the database is created, we can take our connection strings and our passwords, incorporate them into Gremlin so we can connect and run some queries. So while you're waiting for this 15 minutes to provision this database account, would be a good time to go and download the Gremlin console. Once our Cosmos DB account has been created and provisioned, we're brought into the configuration screen. So here's where we're going to need to get some of our information so we can connect Gremlin into this Cosmos database account. First thing we need is your Gremlin endpoint. This is going to be used to connect to the host. We also need to come down to keys and copy the primary key, as this will be used in the password field. So once we get both of these values, we can come into our configuration. So under Apache Tinkerpop Gremlin console, subfolder Apache Tinkerpop Gremlin console, in the configuration folder, there's a file called remotesecure.yaml. This needs to be configured to connect. So double click it and open it up in Notepad. And you want your file to look like this. So my host is my account name, Richard K. Spencer, .gremlin.cosmos.azure.com. My port is 443. The username will always look like this. So it's /DBS /sample database, which is my database name, /COLLS, cols for collections, and then / your collection that you want to interact with. So in this case, it's our sample graph. So we created a sample database And now we create our sample graph. So we created the sample database, and we also created a graph called sample graph. So this is what we need to use for our username. Our password is the key that we took out of the console. Connection pool, we need to enable SSL. And for the serializer, we need a class name, right? And make sure it's serializer version 2. And this can be copied and pasted and saved for later, or you can find the exact one on the Azure website, what you should use. Once you're happy with your remote secure YAML file, we save it and we bring up our command prompt. Once we're in our command prompt, we get to the directory that we need to get. So Apache Tinkerpop Gremlin console, and then cd Apache Tinkerpop Gremlin console again, and then cd bin. Once we're in here, we can take a look at the directory. We can see gremlin.bat and gremlin.sh. So since we're on a Windows device, I'm going to run gremlin.bat. As this runs, you'll see Gremlin fire up. And now you'll see the Gremlin command prompt. So now we want to say remote connect tinkerpop.server conf remote secure. So we're telling it to use that remote secure.yaml file. We hit enter. We get a couple warnings that we can ignore. Then it says configured richardkspencer.gremlin.cosmos.azure.com with the IP address and the port. So the last thing we need to do is to run the remote console command. This will redirect all of our console commands to the remote server. Okay? So now anything that we send in the Gremlin console is being sent to our Cosmos database. So just to run a test to make sure everything is fine, we can run g.v.count. It should return a count of 0. We have nothing in there. And it turns 0. So that makes me feel confident that it is now working. So now we're going to create vertices and edges. So once we're happy that we can connect to the database, let's create some vertices and edges. So let's add a 5-person vertices for Thomas, Mary Kay, Robin, Ben, and Jack. So I'm going to put in g.addv for vertices, person. The property is going to be first name Thomas, property of last name Anderson, and properties and values for age, user ID, and property for the primary key. So I go ahead and hit enter. It spits me back out the ID, what the label is, and all the other output that we can read. So we're going to go ahead and we can add a few more of these. We can add one for Mary Kay. So we just paste in the g.addv command. This is the API. It's going to add vertices. We successfully added Mary Kay. Now we'll successfully add Robin. And we have 2 more vertices to add. Ben, which we will paste in, and Jack. So we'll paste in the API command to add Jack as a vertices. So at this point now we need to add these edge relationships between our people. Okay, so we need to create an edge relationship between Thomas and Mary Kay. So I'm going to add an API command that says g.v has label person, has the first name Thomas. He knows the label Mary Kay. So we're making a relationship here. Thomas knows Mary Kay. We get a successful ID come back. We can add another for Thomas and Robin. So we run the exact same API. And now we've created a relationship between Thomas and Robin. So we're slowly filling up the data to make this graph. We'll also create one for Robin and Ben. So I pass in the API for Robin and Ben. Now we've created our relationships. Now let's run a query against our graphs. All right, so let's try a query with a filter to return people who are older than 40 years of age. So this query looks a little like this. G.V has the label of person, and it has an age greater than 40. So when I hit enter, I get one ID back. It tells me that this person is Thomas Anderson. So we're querying data. Okay? Now let's traverse our graph and find all of Thomas's friends. So in this case, we'll run an API that says G.V. So basically we're saying return the person that has the label person. His first name is Thomas, and bring back who he knows. So everyone he knows that has the label person. It returns us back multiple values, Mary Kay and Robin. So when you're happy with your database, the vertices, relationships, you're done. Now you can add more, or if you want to see it from another side of view, we can go into the console and take a look. So if we come into the console, you'll see that we're in the Cosmos DB. You'll see the sample database we created. You'll see the sample graph. I can come in under graph and I can run the same commands here that I did in the Gremlin command line. So if I execute the Gremlin query, we still get our two results, but we'll also get a graph that shows the relationships. So you can see how important and powerful this can be if you're dealing with a lot of different vertices and a lot of different relationships. So whether it's IoT, whether it's a gaming application, get in, play around with the Gremlin API, and really create some powerful databases that you can incorporate into your application. So in this course, we've examined Azure Cosmos DB. We did this by exploring the Azure Cosmos DB resource model, provisioning, configuring, and querying Cosmos DB, Azure Cosmos DB, and using the core SQL APIs, and using Cosmos for MongoDB, Cassandra, Azure Table, and Gremlin API. In our next course, we'll move on to explore basic management tasks for non-relational data.